Hello everyone, my name is Jianhao Wang, now a PhD student in the University of Hong Kong, working on efficient AI and foundation models in variant and multimodality. I'm very glad to introduce our CVPR 2023 work on efficient foundation model. I-former, keep your variant backbone effective by removing token mixer. Here is the outline of my talk, which contains 7 sections. And I will start with a quick preview of I-former. So this is a paper discussing the foundation model. Token mixers as self-attention for variant transformers are intended to perform information communication between different spatial tokens, but suffer from considerable computational cost and latency. So in this paper, we show how to keep a variant backbone effective while removing token mixers in its basic building blocks. We first developed an I-former architecture to study the token mixer-free model. And then we developed the improved learning paradigm to break the limitation of simple token mixer-free backbone and summarize the empirical practice into 5 guidelines. Equipped with the proposed optimization strategies, we're able to build an extremely simple variant backbone with encouraging performance, while enjoying the high efficiency during inference. We hope this work can serve as a starting point for the exploration of optimization-driven efficient network design. As for background, when we talk about variant-based models, one representative that has to be mentioned is VIT. VIT uses transformers encoder at the backbone of the network and a fully connected layer for the classification task. Transformer makes extensive use of the self-attention module. Subsequent researchers have abstracted the transformer's architecture into a metaformer, consisting of 2 submodules, where the first subblock consists of a token mixer and a layer normalization, and the second subblock consists of a feed-forward network and a layer normalization. The token mixer is not limited to self-attention, and the other components are kept the same strictly as transformers. As for motivation, as the foundation model evolves, the architecture of token mixer calls for a simple direction. Then we ask, can we keep the variant backbone effective but totally removing the token mixer? There are several advantages of the token mixer-free architecture. Firstly, it is an embarrassingly simple architecture. 0 parameters, 0 flops, 0 latency in token mixing, and reducing model latency, power consumption, and memory usage. Moreover, an inference chip specialized for I-former can have an enormous number of layer normalization 1 times 1 convolution units, facilitating hardware specialization to achieve even higher speed. Last but not least, we can focus more on the overall architecture and training strategy of VIT-like models, rather than only on the design of the token mixer. In this section, we present a trajectory going from a fully supervised approach to more advanced training paradigms. For the first step, we directly train a variant backbone without token mixer and leads to a serious performance gap. We now study the knowledge distillation paradigm. Do we use hard distillation or soft distillation? Do we use cross-entropy loss or not? We found that supervised training with a hard distillation does not seem to be the most suitable way for a crude model. Well, pure soft distillation is better, but it still fails to fully recover the performance gap. We then studied the structural reparameterization paradigm. We found that using affine transformation in training without tailored distillation is hard to recover the performance degradation. We then developed a module imitation method, which led the affine module to approximate the behavior of the token mixer module of teacher. This technique helps leveraging the modeling capacity of the affine operator by helping the affine operator of students implicitly benefit from the supervision of the teacher's token mixer. We also found that the teacher with a large receptive field is beneficial to improve students with limited receptive field. And load the per-turn weight of teachers helps improve the performance. As for evaluation, our iFormer shows promising results on ImageNet 1K classification with fast speed. We also did extensive ablation studies to validate the effectiveness of module imitation technique. Through these experiments, the effectiveness of module imitation are validated, and different acceleration strategies are compared as well. We also try some other teacher models such as random matrices, pooling, separable depthwise convolution operator, attention as token mixer. We also do some visualization experiments. Please turn to our project page for details. Finally, as conclusion, we propose to explore the VM backbone by developing advanced learning paradigm for simple model architecture to satisfy the demand of realistic application. We instantiate the reparameterizing idea to build a token mixer-free VM backbone, iFormer, which owns the improved modeling capacity for the inductive bias while enjoying the efficiency during inference. Our proposed practical guidelines of distillation strategies have been demonstrated effective in keeping the VM backbone competitive by removing the token mixer. Thank you for watching, and for more detail, welcome to visit our project page and MM per-turn framework.